Crap, we ran out of music. Sorry about that. Give me a second. I'm trying to load up the post here in Firefox, the questions post, but Firefox is just hogging my CPU. Just come on, it's like at 40% CPU with one tab open. Q&A thread. That's the one we want. Here we go. Right. I think I also know why the hotkeys aren't working that well. So let's just get into it. So 4 weeks. That's June. Crap. Let's actually answer the correct ones. Call for questions. Here we go. And as always, I'll try to answer the oldest one first. And why? I can't switch the cameras here yet. I'll try to answer the oldest ones first, and if you have questions that come up during the stream, that's going to be up on the screen here, and I'll try to get to those. Nope, there. I'll try to get to those live, basically. Have I tried flexible filament in the Titan Aero? Any difference? So first question there. Flexible in the Titan Aero, not really a difference to the regular Titan. I mean, it's still the same geometry internally. No difference. Still prints great. So, first question answered. Okay. Okay. Let's see if I can actually find the ones that I can answer in a. How long is this? 30 minutes? In a 30-minute hangout. How to wire up an MKS baseboard to turn the power supply on and off. I can these hotkeys, man. I can try and touch on that. Basically, you grab your ATX power supply. You find the green wire on the plug right there on the big ATX connector, and that one you connect to the PS on pin. The RAMs has them. I don't know if any of the MKS boards actually have them broken out. But you basically straight up connect this to the board and configure the firmware accordingly, and that turns the entire power supply on and off. Of course, you need something to power your Arduino while you do that, so use the purple line, which is a 5-volt standby that should be able to power all of that. Let's see another question that's really not answerable on a live stream. What do I think about 4D printing? So I did actually, where's my mouse? I did actually listen to a talk on the entire 4D printing topic. So like there are a few things that are called 4D printing. It's self-assembling parts that you print them or create them in some other way. You put them in a bucket, you shake them around, and all of a sudden you have this assembled thing. You have parts that morph by applying heat, that change their shape and like fold each other up. And then you have other stuff like metamaterial printing, where you've seen that door handle that basically has a mesh structure on the back. That's all nice and good, but I don't think it's going to have that huge impact that some media outlets claim it to have at some point. It's just it's a very niche application still, and we really haven't figured it out that much yet. We have proof of concepts, but it's not a real working setup yet. No, this one I want. So 4D printing, nice concept, but not really, not really practical yet. Neo-sanding ironing top layers. I've looked at this one, so let me just open that up and maybe give you guys a view or a glance of what that is all about. Certainly sounds interesting if it would load. So this looks like it is a very nice way of finishing or improving these surfaces on your parts. And yeah, create a process that reprints only at the height of the last layer. So it's basically an ironing or sand with the nozzle. Well, ironing or sanding process that is happening in the printer itself. And yeah, hotkeys. There you go. Basically, you have your top layers. They are sort of rough if you over extrude. If you have your extrusion multiplier dialed in, then you're not going to have that issue anyways. Basically rubs the nozzle over your top layers. So could be a nice idea. I don't think it's really necessary. Like, do I have any prints that have good top layers? Probably not, because it's highly irregular shapes here. But for the most part, I'd rather have a print profile that is dialed in well and that doesn't need any sort of extra hacks. It's a nice concept, it's nice to have, but really you should be doing it in a different fashion. Original Printabot, wooden Printabot simple printers that I no longer use. Think of a more modern machine that I could make from the parts from this. I've got a fair bit of 2020, a few motor switches, usual bits and pieces that one accumulates. What do I think? Well, yeah, sure. So you should, I mean, the original Printabot Simple, the wooden one, probably with the sandpaper pulleys. I mean, for the price point, for the original Kickstarter price they charged, it was okay. It was fine, but like for today's standards, it's just not a great printer. So yeah, basically all 3D printers use the same components. It's NEMA 17 stepper motors. It is the 2GT or 2M belt that's used everywhere. It's a hot end. It's a heated bed. Maybe you probably should be using one. And then the electronics. Like, if I don't know exactly what hardware the original wooden Simple was using. I believe it is an early printer board, and those are actually pretty nice boards. So once he adds some belts, so he has some bits and pieces and stops, etc. Yeah, once you have a few belts and all the other doodads, you could build basically any machine. Of course, the one I've built was there it is, the Dolly, the Mark II clone. You can go for that, but if you're using 2020, so the regular machine profiles, there are a ton of options out there. So go on a forum, go on Thingiverse, go wherever, have a look around what you think you might want, whether you want something large, whether you want something small and high precision. There are options out there for you, and you definitely have the parts to make one. I can't really give a specific recommendation for, yeah, you should be making this exact 3D printer, because again, it's going to be different for every, single situation. Any info related to slicer options, Eric Johnfield is asking for. My Dolly build ran into some issues. Shifting was the big one. Decreasing the perimeters helped hugely. I didn't realize before checking out RepRap's troubleshooting wiki, I had no idea what perimeters were. Although, despite the minor troubles, I'm having huge amounts of fun with my Dolly builds and learning a lot. Thanks for that. So that actually, get over here. That actually got me, why is this refreshing now? This is, okay. This post actually sums up a few things I've noticed over the, what's up with that? Over the last few years, months, etc. There is a need for just a super down-to-earth basics guide. Just, not even starting at, okay, here's your printer, here's how to set up your slicer. No, starting one step ahead of that. Why do you want a 3D printer? What does the tech look like? Even though that's something you assume people would know, because it's been, you know, it's been put out there over and over again. But that might be something, you know, explaining what perimeters are, explaining what infill is, explaining what you know, top, bottom, solid layers do, what those sort of settings do. There's a big market for that. Of course, that's, you know, once you start with that, you do have to follow through and do the entire guide. Bigger project at some point, maybe. I'm not going to be able to tackle that alone. Like my video schedule is crazy full. But yeah, there's a definitive need for that. I'm sorry, I can't really give any. If I would just start out saying, okay, this is that, where do I start? So that will unfortunately have to be a larger, longer series of content, either be it video or, I don't know, even in a written form. On toms3d.org, that webpage does exist too, and you know, written stuff is a bit less work than making the full video around it. So yeah, but thanks for pointing out that there is a need for that. Kind of gets me, you know, away from the, oh yeah, of course you know that, away from that mentality back to, oh yeah, there are people who don't know these things, and maybe I should do something about that. Tisma is asking why I'm not at the Maker Faire Bodensee. No, I'm not. There's also a different one at Friedrichshafen apparently right now. I'm not there. Lucas Correa is asking, I would like to know what you think about the Prusa approach to multicolor printing. I mean, multiple hot-end extruders versus one with multiple extruders. Thanks. So, where's my Prometheus system? Probably in one of these boxes. Two different approaches to multicolor or multi-material printing. Ultimaker, for example, just uses two hot-ends. It lowers and lifts one. And that's basically what we've been doing for a while. We've been, we've been doing the same thing with static hot ends with the E3D Chimera. Yeah, not that the Cyclops is the one with the single non-mixing, which is actually different to these. So the two big approaches that you're seeing today are the Y splitter part. You have your hot end that basically pops into a splitter that has 2 or more filament feeds. The Prusa one has 4 or up to 4. They also have a 2 filament version. And basically the premise here is as soon as the machine finishes printing one color, so as soon as it finishes printing one color, it pulls it out all the way from the hot end past the splitter, and then the filament path down here is clear so it can push down the other color. And that has a few advantages and disadvantages. First of all, you're using the same nozzle for both colors, colors or materials, which is good and bad. It means you don't have any calibration to do, you don't have to set any offsets, you don't have to recalibrate. So that is great. So the nozzle is just going to be the nozzle. The nozzle is going to be at a fixed known position. There is no second nozzle that is at a different position that you maybe don't know exactly. The downside is you do have that, repeated pulling action from, basically from the heater zone all the way out. So you have a huge retract there that takes time. And it also means you have that switchover. So you have one color in the hot zone, let's say a white. You pull it out, you start pushing a blue filament in. Blue is fine, blue is opaque, that covers the white nicely. But as soon as you pull that out, there's going to be some leftover color in here, which you do have to purge out. So with the white filament, you push it in, or the printer pushes it in. And for, I don't know, it's probably going to take up to 10 centimeters of filament that just needs to be fed through to get that blue out, to get the white really white and not like a baby blue. And that is just a priming action that wastes a lot of filament, first off. It uses up a lot of filament for priming towers, and that also takes a long time to print. So currently my favorite approach to dual extrusion is what the BCN Sigma does, with two independent hot ends that aren't just individually controlled temperature-wise, but also move independently. So you can get the one that is idle out of the way, off to the side, over a dump bucket, and the other one is printing just like a single extruder printer. And once that is done, it just moves out to the side, it cools down, it can do that right there. And the other one primes into the bucket on the side, so you have no ooze, no stringies that could catch on your print. And then it moves into the print area and it is ready to go. Of course, if you're doing something like the Ultimaker does, you have two hot ends that are next to each other. The idle one either needs to be moved up, which is what the Ultimaker does, or it's going to be at the same height. It might catch on your prints. It might ooze all over the print. It's just, it both has its up and downsides. Neither one is really perfect yet. So again, the one I like the most is the two independent hot ends on their own motion platform. So if you have the option of going for that, definitely do. Right. I know that if I use a filament that then come back to it 6 months or say later, it becomes brittle. Is there a simple way to revive it? It happens to name brands as well as Chinese chunk. And yes, I do my best to sort of vacuum pack it so it's not just left somewhere. So filament, moisture, absorption. I have a ton of open filament out right here. It's okay. Again, I do have a dehumidifier here, so this is all somewhat controlled. Hygrometer says, yeah, decent moisture content here. The thing is, I've not really seen that degradation that much. Some people say, okay, I took my filament out, I left it out for 2 weeks and now it's crap, now it's unusable. I've not had that happen to me. So far, my filaments, I leave them out, except if it's, okay, so nylons, you can't leave those out for a day. Those will absorb more moisture than you could ever imagine. You do have to bake those. PTGs also absorb moisture to a certain extent. E3D says it makes them brittle because you have hydrolyzation, something, while it prints, which is basically small water molecules bursting up during the extrusion in the hot end, and that basically steams the filament. It does something chemically. So that is something that happens to PTG. The other thing, of course, PVAs do soften. That is just a given. But with all of those, you can try and bake them in the oven. If it's a PLA, don't go past 40 degrees. But for any other material like 50 degrees, basically your lowest setting on the oven. For half an hour, at least, better do an hour or 1.5 hours. That takes out all the moisture. If it's a filament that is brittle, I don't know what that is caused from. What I think what's happening is that it's crystallizing. So if you have a PLA that is regularly, normally that is amorphous, which means it is somewhat ductile, it's somewhat bendy, and you store it at high temperatures for a while, for example, in a shipping container overseas, and you have the sun smashing down on it. I've had that happen where, you get your Chinese import filament, you take it out of the box and it just goes pling, and there's 1,000 tiny pieces of filament because the entire spool broke. That can happen. Usually it makes the filament more brittle, stiffer, more durable actually, overall, but it might not be the best stuff to print raw. So if you got it crystallizing because you've stored it way too hot, then there's not a whole lot you can do. But yeah, if it's just wet, which I don't think white would get brittle from that, then you can try and dry it. Is there such a thing as filament getting too dry? 3D printing meathead is asking. No, not really. You can overbake it, you can crystallize it, but you cannot get it too dry. Chris Petit is asking, have I had a chance to check out the Prusa multi-material upgrade? Same answer as usual. Once Prusa fully releases it and ships it. I think he might ship me one too. So once I get one, I will be able to try it out. But so far, I don't have one. So sorry, don't really have any experience on that. Nope. Do you have a video about adjusting firmware for lead screws? Mason Greg is asking as another one. I don't. What's special about lead screws? The only thing. Well, of course, you need to adjust motion, and that might just be accelerations that you need to adjust, because your motor is turning at a much quicker pace, and you have your steps per millimeter, which you can calculate with any of the online calculators. For example, the Pusher calculator that gives you lead screw calculations. So you just plop that into your firmware, and that's it. There's nothing you have to change other than that. Andrew Gillett is asking, how dry do filament dry boxes need to be? Yours is reading around 25% humidity, which he assumes is fine, but is it? It is. Mine usually read around that as well, which I believe is the lowest my digital hygrometers go. The sensors in them just won't read any lower than that. So that is fine. If it's 25%, perfectly fine. I think anything below 35 for your PLAs, anything below 40 is definitely fine. For the nylons, I've had good experience with anything below 30% relative humidity. That usually keeps it pretty nice and dry and pretty printable. And yeah, I've even found if you keep it at a very low humidity, filament will slowly release that moisture again, and will not need baking. So if you have a very moist filament, a filament that has soaked up a lot of water, you drop it in a dry box that has like a nice thick layer of silica, leave it in there for a few weeks, and it's dried out again. So yeah, 25% definitely more than okay. So that's the same question twice. Right. 50 hours. Recurring problems. See, probe inductive sensors somewhat flaky. How do I get the same results consistently? I can stop the print, rerun, bed leveling it, maybe right one time and wrong the next. Thanks. Replace it with a BL Touch clone. Okay. Replace one solution with another one. So do I have a loose one here? I do have one in this. In this carriage. So these standard inductive sensors, they do have a bit of noise. So they don't always trigger at the exact same location or at the same height. I did some tests on that. I found these to actually be pretty good. But there might just be some long-term drift with heat and humidity and whatnot. I did test them. They were actually really good. They were the best type of sensor you could buy. Also the 5-volt one. The 5-volt one is pretty good as well. But I have noticed that every once in a while it's just a tiny bit off, which usually isn't an issue. And it's about as much as a cheap heated bed will flex when you use a different temperature. So it's not a huge deal. What I usually do to work around that, and to work around any sort of the height inconsistencies, every 3D printer is going to have that bit of an offset. Even mechanical end stops, might sometimes trigger at a different height. What I usually do is I set my slices to extrude the first layer wider and thicker, and that will take up any inconsistencies in the in the bed. If it's if it has some minor bumps in it, if it's just at the wrong height, having that wider first layer particularly, that really helps to smoosh down the filament into the bed. And even if it's a bit too high up, even if the nozzle is too high up, it's still going to extrude enough material to really get that foot down and to stick it to the bed. So that's the one thing I can really recommend for anything, even if you're not using a sensor like this. Set your first layer, I don't know, I use a millimeter wide and usually like 0.3 millimeter wide and 0.3 tall deep. So that really gets stuff to stick incredibly well. All right, best build plate surface to use: 3mm aluminum heat bed and have an induction sensor. Get PI. Very simple. Just get a sheet of PI. I recently, I don't have it here, but I recently put the I recently put the 0.8mm PEI from 3D Prima on a Prusa Mark II, which is fantastic because it's this thick, robust, massive piece of PEI. The sensor just barely probes down to the MK42 bed, but it's really nice to have that nice solid layer and not worry about tearing chunks out. So that stream hung, refresh the page, and not have to worry about tearing chunks out. So that is really nice. Maybe get a thinner one if you want to have that leeway of just using the regular inductive sensor. So yeah, Cura doesn't seem to let you set the first layer width or height. One of them. I think Cura 2 doesn't let you set one of them. Cura 15.04 didn't let you set any of those. So yeah, maybe time to switch to Cura 2, where you can at least set one of those, and that's also good. It's better than printing at the same height and width than the rest of the print. Pigma is asking, what's your current favorite mid-price controller board? Looking at making a dolly using the Mark 1 to produce the parts. Okay, so that's the original Prusa Mark 1. Might be nice to get something a little more reliable. Or do I just need to spend the pennies and get a Rambo Smoothie level 1? So, thing with control boards, I get these questions a lot. Like, what's a good cheap board? And the thing is, from what I feel is like up to, I don't know, the $60, $70 mark, you're not going to get a perfect board. That's been my experience. Chat, if you have any suggestions of what like decent budget boards you can get, I'm open for them, but my experiences are just you're always going to get boards with flaws up until that price point for some reason. It wouldn't be hard to do them right, but it might be just Chinese manufacturers, some sort of philosophy, whatever attitude towards board manufacturing just keeps those mid to low range boards flawed, even though again getting them right wouldn't cost more. So really don't have anything to recommend there. Yeah, do it Wi-Fi, cool. But that's not in the mid-price range. That is it. That's definitely a premium board, which is a very nice board, but probably out of the budget there. Robert, what about the Replicape board now? Are they mature for Delta or Core XY? Replicape has come a long way. My biggest grief with, what was it, 1.5, 2 years? Probably 2 years ago, I tested the Replicape at the time. Just at the time, the hardware hasn't really changed. There's been a new revision. I have the new revision. Replicape manga screen. I do have them. It's still great hardware. I just need to test if the software has caught up, and I think it did. There have been a lot of changes, just around the entire experience basically. So Replicape so far can recommend, but that is with an asterisk. Haven't actually tested the current state of the software. Hardware is perfect. And the last one. What's with the amount of stringing I'm getting with PLA on your dolly? I'm hoping that is this is unlisted, so better. Okay, that is a lot of stringing you're getting. Using a genuine E3D-V6 and rigiding PLA, this Pinchy was printed at 180. But the 180 layer bonding sucked. I get the same results with other filaments in any temperature up to 220. So is he saying over 220 it's better? Retraction settings are 1.5 at 50, which is already more retraction than E3D recommend for the hot ends. Heat break blockages from high retraction distances. That doesn't sound good. Okay, stringing. Basic stringing, troubleshooting. What I usually say is move faster. So if you have your move speed, like going from one point to the next, unless where you're where your printer isn't laying down filament. If it's just a really slow crawl, that's going to string no matter what you do. So set that to a decent speed. Mark II uses 120 millimeters a second for a move, so it's kind of zippy. You can go faster than that, but then you get a bit of ringing on the end. Faster speeds, 50 millimeters a second retraction seems or sounds like a lot. That is quite fast. There might be something going on inside the hot end or with the extruder where it skips something or just doesn't pull out cleanly. So just try some standard settings. Actually, let me pull up the Prusa edition slick theory real quick to see what if it opens up. There we go. So printer settings, custom G-code, well, extruder 1, retraction, cool. 0.8 and 35 millimeters a second. Start with that. You should be able to get good results from that, but if you again, base recipe is for me is always fast moves. The medium speed retractions, 50 millimeters a second might just be too fast also, and yeah, don't retract too much. That's going to cause blobs. If you retract too little, that's going to cause strings. But other than that, just try out a few different things. There isn't like one definitive answer to how do I get rid of strings. But yeah, that is going to be all the time we have for today. I've got to get the next stream ready. I will be testing out these guys. I got one and also have the other one. So these we shall unbox and try out and scan a few things. If you want to join in on that, that's going to be in half an hour or an hour. As always, thank you for your support on Patreon. That makes a huge difference. And yeah, hope to see you in today's second stream this weekend. All right, thanks for being here and see ya.